Hello friends, welcome to VK Lectures. In this lecture, we are discussing the physics question paper for Karnataka Set 2023. Here we have the question. A circular wire of radius A in XY plane with its center at the origin. The charge per unit length of the wire is given to be lambda naught cos theta, where lambda is the charge density, linear charge density, and lambda naught is a constant, with angle being measured from this point, from the x-axis, positive x-axis, and the electric field at this center is what is being asked. Now to solve this, we have to consider 2 points here and here. Now why do we have to consider here? Our charge q or dq is equal to lambda naught or lambda dx. Okay, lambda dx, that's equal to lambda naught cos theta, lambda naught cos theta into dx, where dx is a d theta, where a is the radius of the uh, circle. Now dq, the charge is equal to lambda naught cos theta. Now we know that this cos theta, this is the first quadrant, second, third, and here we have the fourth quadrant. Now the cos theta value is positive in first and fourth quadrant. So here on the right side you have all positive charges from minus 3 pi, pi by 2 to uh, pi by 2, 3 pi by 2 to pi by 2. You all the right side will be all positive quantity or positive charges, and on the other side you have all negative charges placed, because cos theta is minus in second and third quadrant. Now finding the total charge q is integral lambda d x, that's equal to integral lambda naught cos theta lambda d theta. So lambda naught cos theta d theta, that's equal to integral is from 0 to 2 pi, so q equal to lambda naught into 0 to pi cos theta d theta, and this value is equal to 0 because sine theta, when you put the limits, you get 0. So total charge on this circular ring or circular wire is 0. Now looking into the electric field, each point you consider, here you have a point here, and symmetrically opposite side you have another point, and the electric field due to these 2 points can be drawn like this, with an vector pointing in this direction. Now this is a resultant vector r, this is 1, this is 2, and this is the resultant vector that will be in the negative x direction. The force is in the negative x direction. Similarly, this negative charge, if you is there, the electric field, let us consider two points here on symmetrically opposite sides. Due to this point, it will be in the same direction. Again, it will be magnified. The resultant vector will be pointing again towards the negative I direction. So total force is in the minus I direction. So electric field will also be in the negative I direction. Now there is only one option which goes in the negative I direction, that is option A. So you can find this, and the magnitude can be found by integrating from the first vector that you get here. The dE is equal to 1 by 4 pi epsilon naught dq times uh, 1, that is the charge, by a square. So dq is equal to uh, lambda d theta, or you can write lambda dx is equal to a d theta, where a is the radius. So that's equal to 1 by 4 pi epsilon naught dq is lambda a d theta, lambda a d theta divided by a square. So lambda is lambda naught cos theta. So 1 by 4 pi epsilon naught, a and a gets cancelled. Integral lambda naught cos theta is 1 by a. This is from 3 pi by 2 to pi by 2, that's in the negative I direction. Similarly, you get the second term at second term for negative side. So this is what we have calculated for the positive side, from minus from 3 pi by 2 to pi by 2. Similarly, you get this is in the I direction, negative I direction, and again you have, due to positive negative side, that is from the left side, there's again dE. You can, this is right, this is left, or you can write positive due to positive charges or due to negative charges on the. So that's equal to 1 by 4 pi epsilon naught 1 by a integral from pi by 2 to 3 pi by 2 lambda naught cos theta.